that, and you'll find out that there are several different options available to us as we go through scripting, and especially as it pertains to cybersecurity. And tonight we're going to start by taking a look at some of the things that will help us out when we get into the cybersecurity realm. So here's our game plan. Today we're going to take a look at accessing the operating system. I would very much encourage you to play with this a little bit between the end of class tonight and when we get together next week. It'll be beneficial. You'll do a little better as we go through working with CSV files. And we'll get our feet wet in that. We'll get some of the theory of CSV files tonight, and we will get heavier into that next week. The next several classes, we're going to be working with files, accessing, reading, modifying, deleting, adding information to different file sets and systems. We're going to work again next week with CSV files, and we'll have a short quiz. And the way we'll probably do that is I'll lecture till about 8 o'clock and give you the remaining of the class time to do the quiz. It's only 15 questions long. You should have plenty of time to finish it. I would encourage you to take a look at the operating system chapter and the information on CSV files, pardon me, in the textbook before next week. And then we're going to look at functions and data files after that. And we'll intersperse it with some fun little exercises. And we may even break into teams and do some work. That's always a good learning tool. So what we want to talk about tonight is Python and the operating system and how Python works with different operating systems. So it'll work with just about any OS that you can think of. And in most cases, its functionality is going to be exactly the same. So when I say that, this piece of code right here will work on Unix, it'll work on Microsoft, it may work on Apple, hard to say. Apple's pretty much Unix based, so it'll work with an Apple machine. There may be some exceptions to what we're doing if you're using a Mac. Do we have anybody that uses a Mac or an Apple notebook? Okay, Surfaces work fine, don't worry about them. So we won't worry about Macs. Mac, as I said, is built on a Unix core, and Python works very well with Unix. So most of the time we can figure out how we can get what's not working to work on a Mac. And again, if you use the Unix hooks with Macs, it will all work fine. These are a few of the things that you can do in the operating system and within Python. We're not going to get in by any means to all of those. We're going to look at some specific ones, and we'll call those hooks the most common hooks into the operating system. And so the first one we'll look at tonight is os.name, and it'll tell us the name of the user system that we are the operating system that we're working with. Then we'll take a look at get current working directory, and that's a useful piece of information to have, especially if we're doing something cyber related on a computer or on a bank of computers. And then we'll take a look at os.rename, and this allows us to change the names of the files and work with it. And you'll see how it can give you some nice insight into what's going on. So if you're going to work along in the classroom, I'll give you a couple of seconds to go ahead and input this code. Line 8, very simply, we are importing the standard module library that deals with the operating system. We don't have to know what operating system we have. Python's got to figure that out for us. And then we're going to use line 10 and we're going to print the operating system name. So go ahead and take a couple of seconds, add that in, and then we'll talk about it. So you run your code and we expect to see Windows 7 down there, and what do we see? NT. Anybody know why we see NT instead of Windows down there? Way back in the olden days, there used to be two different versions of Microsoft Windows available. One was an NT version or a network version, NT. The other was a home version that you could run on your clunky old 8086 HP at home. And so they've kept the NT, the network designation, for all of the Windows operating systems now because they're all network capable. So if we were to run this on a Linux machine, we'd probably see Linux come up. On a Mac, we'd probably see Unix come up. So this gives us an idea of what operating system we're working on. If you get into a computer in cyber and you can't figure out what the operating system is, these two little lines of code, assuming that there's some Python version installed on the computer, will let you know exactly what you're working with. The next one goes a little bit farther. Go ahead and add line 12 to the code that we've entered already. Piece of code in line 12 will show you exactly the working directory you're running out of. In this case, it's off of my E drive down on my desktop, and it was set up as class 15 accessing the operating system. Now, where this comes in handy, especially in scripting where we change the directories that we're working with, if you get totally confused and aren't sure what directory you currently have set, you could run a quick get current working directory and find out where your files are going to or where you are trying to load a file from that just isn't working out real well. Now, the next thing I'd like you to do, if you take a look out on D2L in the week 9 content folder, you'll notice that there is a text file, should be a text file out there. Is there? No, I bet there's not. All right, if you would, in the current project folder that you're working in, go ahead and create a text file and name it anything you want to name it. Doesn't have to have anything in it, and remember to do that. You're going to right click on the project folder and then select the very first option at the top. Give it a name and maybe a .txt extension. I realize everybody's a little rusty after spring break, but if it's sounded a little too Greek to you or geekish to you, you may want to brush up a little bit over the next week. Once you have that file created, it should appear in the navigator on the left-hand side. And let's go ahead now and create a new Python script. Or you can add to the one that we were just working on, your choice, and add in lines 15, 16, and 17. Make sure that at line 15 you use the name of the text file that you just created. Line 16 is just a marker point for us so we can pause the program. And then line 17 is our OS call. And notice what we do here. We're going to rename our original file to new, in my case, new OS text.txt. If you started a new script, remember to import the OS module at the top. Once you have your script complete, go ahead and run it, and you should see on the navigation bar or navigation column that we've changed the name of the file that we created. And you can see the example of mine there at the bottom of the screen. So why might this come in handy, to be able to go in and rename a file through the program? Maybe I've got data created and I'm going to work with that data, but when I'm done with it, I want to indicate that I've completed all my actions. I could go through and say OS underbar text complete and rename my file that way. Or maybe I have a working file of data that is copied from a master file. I might copy that master file over and then rename it working data so I don't delete my master file. So you'll see when we get into working with pickling and working with our CSV files that we can go through and make changes to those file names very easily. Now, you may be sitting there saying, Byers, wait a minute, I'm looking at my navigation screen, nothing is wrong, I don't have any red lines, but it didn't work. Go ahead and close your project folder and reopen it, and you'll see your file there. That is one of the little peccadillos, if you will, in PyCharm. It doesn't necessarily every time update that navigation column immediately. Open and close is one way to do it. Another option is to hit F5 on your keyboard to do a screen refresh, and that may also bring it up. Ultimately, you could look in the directory where you wrote the file to see if it's there. Question, Anthony.
So if you're doing 15 through 17, would you like do your text first in the first file before you run your code?
Yes, sir, you would. Okay, let's go a little farther. We can take a look at the environment and find out the name of the user logged in. That could be pretty cool. We can do OS walk, which will give us a list of files, and this one I will caution you on right from the start. This will generate a list of every file that's on the computer. So if you don't have a lot of time to wait, I wouldn't use the os.walk, but we'll play with this here. Then we can also give systems commands like a ping command or cd to change directory if we want to, and we use that with the os.system. And we'll take a look at how some of these work. Go ahead, if you would, and on this example at line 14, I added OS environ, and then I put in username. Please note, unlike most of the reserved words that we use in Python, username in this case is in all caps. And it also is surrounded by square brackets instead of parentheses. All right, and as you can see, when I ran this code, my username is tbyers, at least on this system. Any questions so far? On the surfaces and people that are using laptops, any problem in getting the operating system code to work? Works pretty well, cross-platform. For the walk statement, you might want to try a set of code like this. We use a for control loop statement. We want to take a look at the root, the directories, the files in OS walk, and notice how this is coded. OS walk parentheses, the drive letter in quotation marks, comma, top down. So I want to start at the top of the top of drive E in this case and list the documents from top to bottom. You could also go top down false and it would list it in the opposite direction. Notice how we do the printout. And I printed 20 stars in between each one of the root directory and files so you can see how this is broken down. Again, if you're looking at a 5 terabyte hard drive, which are very common these days and can run you under $100, you might be sitting at the screen for a while.
What does that say? I can't read it.
Which one, Satchel?
Very for root.
For root, comma, dirs, comma, files in os.walk. And then parentheses, quotation marks, large E colon, /, quotation marks, comma, top down equals true. Remember to put true with a capital T.
Why'd you print the stars?
As a delimiter between each one of the entries. If you don't, everything tends to run together, especially when you're printing some of the numbered files out. Now notice on this example, I've changed it a little bit, and I've actually gone into a subdirectory on the E drive to print out the information there. So you can see how that's done. This is probably one you want to try after class at home or over the weekend. These get a little complicated to type in at times. But what we're looking at in this case is the E drive Python projects fall 2017 fundamental class scripts. Everything is a / when we're doing it this way. Of course, the print statements all tend to be the same, and then you can see what's printing out underneath. We've got a directory name, a directory folder, if you will, and then the actual ID file and what's included in it, then the different Python scripts that are included in that folder. Question from someone? No? Okay.
So I'd assume, like, if we're doing this on our own, we would just change the drive letter.
Yeah, if you're doing this on your own, unless you have a drive, letter E, and my folders and script names, this will not come out for you. Good question, Chris. I've actually had somebody try that. Yeah, you need to plug in your own drives here. I'm sorry. Yes, don't type in E drive. You're not going to find anything. Sorry about that.
Yeah, I did that at first. I was like, yeah, there's no E drive on here. Let me.
For yours, start with the C drive. Just put in the root drive and see what it'll do for you. And now it works, right? I'm sorry. I apologize. Hey, we were all on spring break. Come on. So, how does this become useful for us? You've got 5 minutes to go into a computer. You want to see what files are on it because you suspect somebody is doing something illegal on it. You target the directory, you run this little program. You know that you can print this out or save it. If you modify the program slightly, then you can take those files, that information, and study it. All right. You'll find out, especially in scripting, there are a lot of little 5, 6, 7, 8, 9, 10 line scripts that can do a lot of legwork for you. In fact, next week in the scripting class, we're going to create a 10-line keyboard recording program, which can be a lot of fun. Now, we talked about being able to use system commands within the OS module, and line 16 is an example of that. os.system and ping. Who can define what a ping is for me?
The computer goes out and checks to see that something's there.
It goes out to check and see if something's there. Exactly correct. Now, I apologize, I can't remember where that address is, so you can try and ping it, but you'll get a response back once you run the program. And it'll look something like this. So go ahead and put in that information, line 16, run it, and see what kind of results you get. Of course, one of the things you can do is bring up Chrome, go out to the Google site, copy off the address and paste it in, and that will work extremely well also.
So after the dash T, you just put in the website?
You put in the website numbers, yes sir.
Is there a way to do it without the IP address? Like how you do in DOS for a command, you can just type ping and then whatever the URL is?
Good question. Try it.
How many times will it ping before it quits?
If you don't put any flow control software in, forever, Lisa.
Excellent.
So what you might want to do here is for count up to 10 and ping it that way. Chris, how did it work when you put in a URL address?
Trying to figure out what else I could do on my just on the
Put quote marks around it?
Does the negative T need to be in there as well? Or
Absolutely.
Yeah, put it CNN.com and go with IP address.
Okay, so we pinged CNN and it worked. So you can use the number designation or the actual URL. Let's put on cyber hats for a second. Why would I want to use the octal codes to ping out to sites? Think about that for a while. Let's say I want to look and see if there are any computers available on 10.55.11 between the range of 05 and 255. Would I have to type all that out? No, not really. I could set it up as a for loop and use that last octal as part of the count in the for loop. So this would be the beginnings of a script that would go out and tell you the names of the computers on the network, should you want to find that out for some reason. Okay? We're going to use the OS library beginning next week. We're not going to use any of the exotic commands right now, but get yourself comfortable with the file commands and the directory commands, and experiment if you have time with some of the other ones that are out there. By the way, let's talk about how have we handled data up to this point. And remember, data is what we use to create information to make decisions with. So up to this point, how have we handled the data that we've used with our Python scripts? Well, we've hard-coded it. What does that mean? Hello? We typed in all the code manually. Absolutely correct. We used a text file, right? Not too hard to generate. Can be a little cumbersome. Can cause us some problems. And we've had user input. All right? When it's hard-coded, we don't have to worry about reading or writing the data. With a text file, we have to be able to load it and then try and write back to it, which can create some problems. End user inputs, very dangerous, right? Always. So now, what's the real problem? We need an easy way that we can access this data to create the information that we want. And also right now, we can't easily save what we have created. The problem with the text file is how do you control how much is read in at any one time? And remember, we took the look at reading a kilobyte of data in at one time. And it caused some problems for us. So what we can work with is CSV files. And that stands for comma separated values. What do you think of when you think of a CSV file? Anything.
It's an Excel format.
An Excel format, gold star, exactly. CSV files are structured data, all right? They will always be set up in the same manner. If you have a CSV file, you can handle it exactly the same in almost any case. The big thing about CSV files is that I can transfer them cross-platform and cross-application very, very easily. You look at just about any Microsoft product that's out there. Almost all of them, including PowerPoint, give you an option to import a CSV file. You look at Oracle from a database standpoint. Oracle not only allows you to generate a CSV file, but it allows you to create them with an Oracle database. So if Big Brother Oracle can use CSV files, so can we when we're working with Python. And we'll find out over the next couple of weeks why everybody likes to use them. Because, believe it or not, they're relatively simple to work with. Now, pardon me, like I said, spreadsheets, databases, other types of data repositories. Actually, I worked with some equipment out at Tinker that read RFI chips, radio frequency chips, that were attached to different components. And those readers would generate for us CSV files that we could then process in Oracle. So there are a lot of different repositories that can provide you these CSV files. CSV is really a file structure, and we'll look at one so we can decipher it here in just a second. Generally, when we think about CSV files, we think of data in a row. And it could be a single piece of data, or it could be a couple hundred pieces of data. We have, when we start to talk about data, something called a data instance. And so an instance, if I created a CSV file for students in fundamentals at 7:05 on Wednesday night, an instance would be the data that I would collect about you. And so in a CSV file, your data would more than likely occupy one line of that CSV file. Again, the comment was made that it's just like a spreadsheet, and that is exactly the best way to think of it. Each row in a CSV file should reflect a different value. And when we talk about value, substitute the word instance in there. So if we did a CSV file again for the classroom, each row would reflect you and only you. All right? Maybe designated by your last name at the beginning. Multiple rows or multiple items within a row are separated by a comma, hence CSV file, but we don't always have to use a comma. By the way, in Python, we don't have to set the comma off necessarily with quotation marks like you do in some other systems. We could use a space, we could use an asterisk, we could use just about any character that we want to. What would the stipulation be for the character that we select? As an example, if I use a comma for my CSV file, what am I stipulating? That the only way that comma will be used within the file is to separate values on a line. So if I was using numbers and I had a comma separating the thousands and 10,000s point on a number, that would screw up my CSV file. Processing is handled by a module in the Python library. It's called CSV. We can import it very simply. Import CSV, very easy command to use. And the next slide is going to show you some of the most common things that we can do with CSV files. We can read, we can write, we can change the delimiter. We won't do that initially. We can write out one single row of data, or we can write out multiple rows of data if we want to. And we can also read something called a header. Let's say that I set up a CSV file for our class, and I had last name, student ID number, and current score. I could put that across the top and then read that out with the command read or write header if I wanted to. So go ahead. For this one, we'll use several classes. So create a new project folder in PyCharm, and you might want to call it CSV files something that will let you know that it's associated with CSV. And what we have on the screen is actually an Excel spreadsheet that contains in the first column the barcode student ID number for each of the students that's listed. Notice also we have that student ID number listed as a text value also. And then we have the last name and the first name. So this might be a way that we wanted to start off a CSV file for us to work with within Python. Now, if you're going to use an Excel spreadsheet to do that, make sure that when you export it or save it, you save it as a CSV, comma, delimited. And you'll notice in some versions of Excel, there is more than one CSV file type. This is the one that we're looking for, the comma delimited. All right, now, out in week 9, there is a folder called Student Barcodes. Go ahead and download that if you would and put it in the folder that you just created. Once you get it downloaded, you can drag and drop it into that project folder that you created. In fact, that's probably the easiest way to do it. Also, the Python culture says, and you don't have to adhere to them if you don't want to, but if we're creating a comma-separated file, we'll use the extension .csv on that file. Do you have to? No, but it helps keep the confusion down if you have several different people working on your project or a professor grading the work that you turn in. Everybody have the file in your folder or sitting next to someone that does. Let's go to the next step. If you double click on that file, you can see how it's set up. Notice kind of unusual on the header row, I'm using ID, comma, last name with a space, and then a comma, and then first name with a space. So you can scroll through that file and you can see what it looks like. So let's start our first CSV project. First thing we're going to do is import the CSV module, line 8. That's pretty simple.
So we just create a new file.
Yes, sir. Can anybody tell me when we do this, and the example on the screen shows it, import CSV is grayed out? Anybody hazard to guess why? Exactly. We haven't started to use the CSV module yet. That's coming up. So line 10 should look a little familiar to you, but we make a couple of changes. First of all, you can use any variable that you like. I like to use data file so I know where my data is coming from. as opposed to an information file, which is where I'm sending information to. We use the open statement, and notice our file name must include .csv. Then we have a comma, then an R. The way that file is set up on the screen right now, what will you be able to do with the student barcode file? Read it. Can I write to it? No. And that's a good habit to get into. If you have a data file that you are not going to modify, open it as a read-only file, an R file. That way you will never run the risk of destroying your data. Once we've got it open, we want to read that data. So notice we're creating a series of steps here that'll make it very easy for us to read our information in once we get done. First we created the data file. Now we're going to create a CSV reader. Again, like with the data file variable name, line 12, my reader, you can call it anything you want to. Just over time, I find out for me, my reader seems to be a variable. I can always remember what it is. Notice how we create the reader. We have CSV open, which means we're going to the module now, and we're going to select that part of the module that contains the reader, so .reader, and then we're going to tell it what we're going to read, and that would be our data file. Now, it's totally permissible in line 12, where we have data file, to plug in open studentbarcode.csv, comma, R for read, with all the appropriate quote marks. It just makes it a little cleaner if you create a variable for that. The other thing it does is if you run into a coding problem, it's a little easier to troubleshoot if you have variables that indicate different processes in your script. So now we're kind of starting to get into the coding and the nitty-gritty part of setting up Python scripts. Now, the only thing we have to do is create some kind of flow control so we can print our information out. So line 14, we know for is a flow control statement. Let's see, what do I want to call the information or the data I'm pulling out of my reader? Oh, it's normally in rows, so I'll call it a row. And then I'll have a print statement. Now, you all know my preference for dot format. You don't have to use the dot format command if you don't want to. But notice how I have it set up. I'm reading the first piece of information in the row. That's row 0. Then I'm tabbing over. I'm reading the second piece of information in the row. That's row 1. Position. Think of those numbers in brackets as positions. And then finally, I'm reading the data that's at position 2. If you still have open the CSV file we looked at, you notice that equates to the student ID, the last name, and the first name. And so when we run it, here's the information that we have. Notice it automatically read the header data for me, even though I didn't tell it to. And then we get a nice list of all of the students that are enrolled.
By header data, do you mean student ID, last name?
Yep,
first name?
ID, last name, first name. Yep.
I guess I'm not surprised that it did it because it doesn't look like header material in the file. It just is.
Yeah.
It's header to our brains.
Yeah. In Python, unless we tell it to read the header, it assumes that every row in that CSV file is a data row. If we say read header, then it will take whatever the first row is in that CSV file and create it as a header. If I used read header and didn't have that first row there and started with Mickey Mouse and his information, it would take that as the header and print it as the header data. Probably wouldn't make a big difference in this case, but in some CSV files it would. So, that's really great, but we don't want to look at every student that's in a class, especially if it's a lecture hall class, 225 down at OU. So we can modify row 14, add in row 14, and put in find student, input, enter a student number. Then we modify our for statement, and we still have rows in my reader, but now we're going to say if row 0, which is the position of our student ID number, equals find student ID, then we're going to print the information out. And if you run the script that I have on the screen and enter Wilma Flintstone's number, you notice it will print out her name. Now I want you to think about line 14 and line 17. What do we need to keep track of? And this is something that you as a programmer would have to do. End user will never think of it. What you need to keep track of is how is that student ID number stored. Is it stored as text, which means it would be a .csv file, or is it stored as a numeric value, which means it would more than likely be stored as a binary file? So, one of the rules of the road using CSV files is that assume everything in the file is a text value. Now, think about this before you answer. Let's say that within our CSV file we have the grades that Mickey has made on several tests. Because I have it stored in a CSV text file, does that mean I can never figure out what Mickey's final grade is using that file? Any thoughts? The answer is yes, I can. Because I could very easily, if it was row 2, put the word or put the reserve word int parentheses row square bracket 2, and what's that going to do? It'll turn the value of the row 2 input into an integer, assuming it's an integer. What happens if there is a character value there? We'll get an error. Okay? But it is possible in a CSV text file to do math if we wanted to do that. This is the way a program, a very simple program would take could be set up to read and write file attendance data for a student. In fact, this 4 semesters ago was the start of the scanning program that we used at the beginning of class. And so you can see how we're using a CSV file to read and write data out. And if you look at it, we're importing the CSV module, we're importing the date time module so we can get a date. We've created a module called data write, and it's going to write data and a path, so we know that we're going to determine where information is going. And then we'll get into writing our own modules around week, this is 9, 10, 11, probably week 11 or 12. We'll do a little more work with that. You can see we've got new file open. You can see that we're writing a line of data. And then our control portion, we're actually creating a list. Remember, a list is indicated by square brackets. We're picking up a time, and now we're entering somehow the student ID, then the date stream, and the name of the class. And this runs the loop until there's an exit made. Oh, I thought I had the sample. I'll show you the sample of that next week. All right, good session tonight. We've covered quite a